Hello everyone, I am Himank and I am co-founder and CTO of Tigris Data. Tigris Data is a globally distributed object store that is store data close to user. So we provide high performance S3 compatible storage. And my today's talk is about something that sounds simple but has quietly reshaped the cloud, and it's about how S3 API compatibility lets you use any cloud. This slide is not about multi-cloud, but actually some very simple concepts of how you can design interfaces and how systems should be built. So let's dig into it and then we will talk more about it. So three key takeaways from my slide would be first, portability. So portability is the core design principle, especially for the modern new clouds. It's not a backup plan and it's not a second choice, but now it's becoming the default choice. Secondly, portability comes from standard and interfaces, not from the infrastructure. You cannot wire multiple clouds and stitch them together and call it portability. That won't work. And for storage, S3 is the portability layer. The common thread between these takeaways is one word, and that is interfaces. And to understand why, let's zoom out a bit and let's talk about this. So here is a simple but powerful idea that many implementation gets rewritten, databases gets rewritten, control plane keeps on changing, and in fact the whole cloud stack in many cases also gets changed, but interfaces it stays, and actually interfaces it stays for decades, and S3 is a very good example. So S3 didn't win because it was the most elegant design system, but it won because it has a super simple interface that made it so popular from the adoption perspective, as well as we started seeing more and more S3 provider coming in that are S3 compatible. So from user perspective, it gave many options, plus its simplicity let S3 so popular. But now if there are interfaces and there are interfaces out there already, then why is portability so hard? And for that, this image captures it perfectly, that you have a cloud, you're using a cloud, you have a bunch of services. Now all these systems are speaking different dialect, and even the cloud APIs are different. Each cloud has different APIs, and now you stick all them together, you start using it, but now you need to move. And now if you need to move, you need to rewrite bunch of services, you need to add bunch of converters, adapters, and it's whole mess of writing so much code to move to a different cloud. And this is why portability used to feel impossible, and this chaos is exactly why standards are so important. Now standards. So standard enable choices. Portability comes from interface, not infrastructure, as I mentioned in a previous slide as well. And here we have some good examples. So when compute exposes Kubernetes and OCI, when network exposes TCP/IP, DNS, HTTP, TLS, and when storage speaks S3 or POSIX, then what you are doing is basically you are decoupling what you run from where you run. And this is a very important differentiation between when you start building your design in a way that you can decouple it, that what you are running from where you are running, then you start having more and more options and more choices. Now compute and network got their standard. They have Kubernetes, OCI, they have TCP/IP. But let's talk about storage a bit more. Now again, recapping on why S3 compatible storage is so portable. So first, we talked about interface. S3 has a very simple interface. It lets you do so many things with just small set of APIs. But there are other things as well. So S3 doesn't have a concept of schema, transaction, and coordination. And it is intentionally left like that because it wants S3 to be lower level and have databases pull in all these where it belongs. And now we are actually seeing a latest trend when databases are actually building on top of object store or S3 compatible object store. SlateDB is a good example, and I think we have a talk as well next, which is building on top of object store. Then there are some other databases that are moving durability or recovery out of the engine and moving that to object store. And then there is TIDB serverless offering as well that claims to be completely using S3 compatible object store for their content. Now, one of the thing is they are moving out complexity out of the engine, moving to the object store. But the other is this is actually making these databases portable as well, because now their underlying engine or underlying storage is actually portable, which is S3 compatible. They are not relying on a single provider or single cloud. With this, they get the flexibility to actually make the database layer portable as well. Now, what use any cloud actually means? So, first of all, just a pause here that we are not saying that you're just waking up and changing your clouds or moving the workloads to any other cloud. But the focus is that how you can make your design so portable that if something changes, like cost spike or there is some shortages, like GPU shortage is a good example, or if region failure happens, or if there is some compliance changes, then you have a way to redeploy to a new cloud. You are not thinking about migration to a cloud, but you are focusing more on redeploying. And this is and in fact, in most cases, we have seen most of the companies are not even multi-cloud; they are just single cloud, and which is perfectly fine and makes sense as well. But they are option rich because the design itself is portable. So if the design itself is portable, that allows them to move if any changes happens. And this mindset is exactly what BYOC platforms are building around. So BYOC platforms makes portability a design default. They assume that the workloads are expected to move. They are mainly using only standard interfaces like Kubernetes, OCI, S3, TCP, IP, and all durable state lives in S3 compatible storage. And with all this, what BYOC platforms achieved is that moving cloud just becomes redeploying, not migrating. They can actually have their clusters reattach to a completely different cloud with the same state. Now, let me ground this with some few examples. So, for example, here we are talking about 3 platforms. They are sharing just one principle. Neon, for example, you don't need to rewrite your software based on different environment. Northflank, a portable control plane. SkyPilot, you can move compute when it makes sense. Now, these different product just sharing one same principle that they are using cloud just to run the workload, not where their system lives. They are focusing on standard interface and so that the workload can run anywhere. These platform makes compute portable, and Tigris is trying to do the same for data. So Tigris is making data portable similar to how these platforms are making compute portable. And if we think about this or if we try to have synonymous to previous slide, so if just to think about it is like how Kubernetes made compute infrastructure agnostic, the same philosophy applies for Tigris. Tigris is doing the same for data. So your data becomes movable. You can reattach it anywhere, and you get the freedom that you can deploy your applications in any region or any cloud. Because Tigris is changing the way how data can be close to compute, which means now you are not worrying about that your data is siloed to a single vendor or to a single cloud. And if you look under the hood, for all these platforms, they share the same foundation. They are using Kubernetes for compute, standard protocols for networking, and S3 compatible object storage to store the state. Now, none of these platforms assume that you will keep on moving your workloads in the cloud, but they are mainly focusing on that if you need to, then you can just redeploy, not remigrate. So, it's mainly focusing on operational consistency, not worrying about the migrations. And now, what does this mean that how you should design your system? So, that leads to some small principles that I want to talk about next, that the BYOC platform bake in few principles, and the first one is simple, but it's a little bit mental shift, and which is that your system shouldn't live in a cloud, but it should run in a cloud. So, basically clouds are execution environments, not platforms. But if clouds are just execution environment, where should your state live? So, your state should live in storage, and basically your storage is the meeting point across the clouds. And data is traditionally hard to move, but with Tigris is flipping this, because Tigris is making it easy to move data close to compute. With this, you have some simplification, because now machine can have temporary state, and then your state can be moved out to object store. Now, once your data is portable, once you have made your state portable, then you can have much more options. Then you can use clouds based on your different workloads or different requirement. You could have GPU heavy training jobs running in some cluster or some cloud. On the other hand, you could have use cases where you have latency sensitive APIs running and deployed somewhere, or some compliance workload isolation requirement. So, then you can accommodate bunch of different requirements because you have the state which is outside. And just to recap again, the design is focusing on redeployment, not migration. Basically, how easy you can redeploy compute, reattach your storage, you can replay your logs, and you can just have your caches warmed up in any new region. Now, this leads to one caveat here is that people often think that portability means that they cannot use managed services, and which is completely wrong and a misconception. In fact, in most cases it makes sense to use managed services. The only caveat here is that we just need to be cautious when we are using any proprietary APIs from a particular or any cloud or any provider, because those APIs are the only one that can make you vendor lock-in, and that can close you to a particular cloud. Because otherwise, if you are using a standard, you can use managed services because these are standards, so you can easily move to any cloud. So, stepping back and concluding, so S3 compatible storage is the backbone of portable workload. It's mainly about operational consistency. You are getting options, and you are not worrying about migration, but you are focusing more on redeployment. But there are secondary benefits as well, that performance, that your workloads are now co-located. For example, with Tigris, the data is moved close to compute. Compliance, you are not worried now because you can have isolated environments as well. Cost, you will have more options, and vendor lock-in. You don't need to worry about vendor lock-in, you can choose the cloud. And if I had to summarize finally with a single line, so Kubernetes made compute portable, protocols made networking portable, S3 compatibility did the same for storage. And now Tigris is unlocking a new level of portability. Your data moves near your compute by default. That's the core idea I want to leave you with. Thank you.
Thanks. That was an amazing talk. But, questions, anybody? Yeah.
Thanks for the talk. So one question I had was, how do you think about not using the non-standard APIs versus the extra pain we would need to go through uh, by using only the standard APIs? Like, to give an example, conditional writes. AWS introduced it last, and so when you're building it now, you have an option. Either you rebuild conditional writes, which are quite hard, or you build on like GCP or Azure till you hope AWS achieves conditional writes and then you do it. So in general, how do you think about it? How do you think people think about it?
Yeah. So I personally think that we should opt for standards as much as we can, but there are obviously some cases where there is, for example, a small use case and you don't want to invest too much on that and you are going with some proprietary or some custom APIs, but you know that in the long run that it will still be small use case. Otherwise, if you opt for a standard, at least in your major product, then even though you spend some more time in using the standard, it will benefit you in the long run, because then you have a lot of options. Then you can at any point, GPU is a classic example. You don't know where you will get it and you don't know which provider is costly. Now if you have options, if you have already spent time in making sure your product is following these standard APIs or standard interfaces, then you can just switch quickly to any provider or any cloud without worrying about at this point rewriting your stack and spending time before you have the option to choose. So that's the cost angle between using something that is not standard versus choosing something that is standard. So think in terms of just cost.
How do you think about the benefits of standardized APIs like the S3 API compared to like abstraction layers that abstract over different APIs? For example, in object storage, I guess there's very few people like interact with the S3 API directly. They mostly go through abstractions that work on top of Google Cloud or Azure and abstract out the underlying APIs.
At least in our experience, we have seen most of the people are just using standard S3 SDK, and there are a lot more folks who are just directly using those APIs, and which allow them to switch as well. But even if there are wrapper around on top of it, even then switching for them is just URL change, because they know that they don't need to worry about changing the underlying implementation. So let's say even if you build on top of object storage APIs, even then if you're changing any underlying storage, it's just about just changing the underlying implementation to point to the new provider or in the S3 compatible object store. You don't need to map it to your own code again if they expose something different. I mean, you can do it, but still it would be very easy for you to port because they are same, their APIs are same.
I have a question, kind of related to your analogy with Kubernetes, and Kubernetes sort of being this like, essentially compute target, right? That you can kind of, target and essentially leverage for portability. However, over time, as we all know, like every Kubernetes flavor is a little bit different, right? And so if let's say you're distributing via Helm chart, or you rely on some like underlying CRDs or something like that, it can be different and can cause kind of push the complexity there. How do you think about that from like the lens of like S3 and what you guys are doing? Like, how do you prevent that? Do you see that as like a risk? Are there some differences in the sort of, S3 protocol versus like what Kubernetes abstraction layer looks like?
So if I just talk about the S3 compatible perspective and how we have the same, are you asking mainly that how you ensure that you have the same compatibility with other S3?
Yeah, or even further, like how do you ensure your customers don't have to like suddenly become S3 experts because all the tools they're using are using specific features or something like that that grow.
Yes. So at least in our case, I mean, there is a long tail. There is a possibility that something doesn't just exactly map, but we try to ensure that whatever works with the standard SDK, that works in the same way if they use Tigris, and there are no surprises. With that, what happens is that they can just use any standard S3 SDK, and that will just simply work with Tigris. Same applies to any roles, IAM roles, or any third-party tools as well. As long as the third-party tool is S3 compatible, we try to ensure that that will also work with Tigris. And at least we have not seen that drastic difference between anything that is working with S3 is not working with Tigris. So it almost works unless there are like in past there are bugs that we have fixed and making sure that it's compatible in all the cases.
Awesome. Cool. Sounds like that was all the questions. Let's give another big round of applause to Tigris.
Thank you.